Understanding the recursion step. Uh, we'll be understanding the recursion step by step. So the things that we are going to cover in this video is like what recursion is, why recursion is used, base case versus the recursive case, how the call stack works, and practical Python examples, right? So this will be the tutorial, which is quite ideally perfect for the beginners. It can also be used for the interview preparations and the logic building, right? So first and foremost question, like what is recursion, right? So basically it's a way, when a function calls itself, right, to uh, you know uh, move sort of backwards and solve a smaller version of the same problem, right? So if you would have heard about the problems that are given generally in coding, which are related to solving a factorial or solving a Fibonacci series, are basically the real life examples of the recursion, right? So that is basically the recursion is all about. The two mandatory parts of recursion are uh, the base case, um, which is basically the condition where the recursion stops and prevent infinite function calls, right? And second one is the recursive case, where the function call itself with a smaller input without a base case, right? The sorry, without a base case the program crashes. That is something that you can have a look on the Stack Overflow as well, right? So let's say we talk about a simple very small case of a recursion where I have put up a def countdown, right? And if let's say if n is equal to 0, just return a blank input, or otherwise print the value and then go down. So let's say if I give you n, so it will first print 5, it will do a countdown n minus 1, then it will take 4 and it will display 4, then 3, then 2, then 1. But if n is equal to 0, it is going to give a blank output, right? That is one of the cases. The other case is the factorial one, which is one of the most common discussed, um, uh, I would say, the coding methods that is also asked during the exam preparations, and it is also discussed during the coding interviews, right? So recursion is a prime example, not necessarily the factorial one, but things or the problems that could be related to the factorial, right? So let's say if I talk about the factorial, we will run these programs in the end as well, to talk about the how the factorial gets executed. So uh, basically, if you would see in the factorial code that has been written over here, so basically if the value is n is equal to 0 or n is equal to 1, so basically you would have seen in the math that there is a thing called as factorial. So when we try to give the factorial of 0, it gives you 1, but if we give the factorial of problems like let's say 5, so it will be 5 into 4 into 3 into 2 into 1. So basically the program will be written in such a way that it is going to call itself and it is going to reduce the value every time. And finally, if the factorial reaches a value of 0 and 1, it is programmed to return you 1. Otherwise, it is going to keep on returning you a value which is n into n minus 1. That is 5 into 4 into 3 into 2 into 1. So that is the value that you are going to 1. And finally, it will be multiplied by 1 and you will be getting a 120 value, right? So basically the values are written backwards, which we are talking about, right? And this is where people get a lot of clarity. So let's say let me open a new screen, right? Let me open a new screen. So let's say if I talk about factorial, right? So I do not want to run the use case because you might have seen the use case, and you might have tried to run the use case multiple times and you would have seen the results as well, right? So there is nothing new about it, but how it is running. So basically when we do the 5, right, so it takes factorial, the a program will take 5, or you can say the method will take 5, and then it will do 5 into n minus 1, which is basically going as 5 into 5 minus 1, right? So that is the first one. Then it will again, since it has again called uh, this value, so it will since it has again called this factorial one, right? So this is 5 minus 1, it has again called this value. Now it has done sorry, my bad. So it will do 5 into 4. Now it will call 4, and now it will keep 4, and then it will do an n minus 1, right, which is n minus 1. Now since the n value is 4, so it is going to be 4 minus 1, right? So it will come like 3. Then it will do again an n into n minus 1, right? So it will become 3 into 2, right? So that is what, once it calls itself again through this particular program. So how it is calling the method itself? It is calling this method itself by doing this, right? So it is going over here n minus 1, right? So now it will again go, now instead, or now it will do 3 into 2, right? So it will return 3 into 2, so it is going to do 3 into 2. And then finally, once the value is 2, now you do 2 minus 1, it will become 1, and it will take 1 as the output, and it is going to multiply it over here, right? And that is how the program will come to a total value of 5 into 4 is 20, 23 is 160, and 160 into 2 is, 23 is 60, and 60 into 2 is 120, right? So I hope this part is clear to you guys, right? The second part over here is the Fibonacci series, right? Now basically, if we talk about the Fibonacci series, is that basically, if you would see over here, I have written some points. So it is basically where, you know, each number is the sum of the previous two numbers, and if you would print these values, so let's say if I give a certain value like 6, so it is going to back run it like Fibonacci n minus 1 plus Fibonacci n minus 2, and it will give you the resultant output, which is going to be which is going to be 8 in this case, right? So I would request you guys to, you know, uh, basically run these use cases on your behalf and try to understand, you know, how basically you are getting over this values, right? So that is basically so these were some of the use cases, you know, that we have discussed. And one thing that you know, and that is important to remember, is that there are sometimes Fibonacci is slow, and basically you also get the performance issues. Uh, Sometimes we you know, also forget about the base case. So, you know, as recommended earlier, if you are forgetting the base case, or you are not keeping in mind that, you know, you have to stop at some point, you can get infinite loops getting created uh, through the code, you know, where basically the code is going to run forever and forever, right? So basically avoid such values, do the proper you know, base case calling in order to reduce the issues, right? You can see the example of the error over here. So let's say if I call this function, I'm not calling this function right now, but if I call it, it is going to run it for infinite number of times, right? So what are the best, you know, places where we give the good you know, places, you know, where we can apply, or the application of the recursion can be made? So that is the tree traversal, graph algorithms, divide and conquer techniques, and backtracking algorithms, right? uh, it is best recommended not to use recursion when simple loops can solve it. And recursion is basically the function calling itself, whereas the loop basically repeats on the condition. The uh, Sometimes I would say that the recursion code is sometimes cleaner to write, whereas the the loop code is sometimes more faster and efficient. So I can give you some 2 and 3 examples, like write a recursive function to calculate the sum of first 10 numbers. That is something that you can try. Write a program to reverse a string using recursion, and then check the palindrome. Right, palindrome is also one of the famous examples of doing it through the recursion. Power of number x raised to power n. Right. Now finally time to run these values and see how the things are getting displayed, right? So we already have factorial open, so let's see how it works. So I will run the factorial one first. So let's try factorial. Okay, fine, you got 120, right? But how we are doing it? Okay. So basically you can see that sorry, it won't be explained to say, but we can do this like this, like you can do, instead of return you can do print. Maybe that will suffice the point, right? Anyways, I'm trying to just debug it. These are some of the ways you can debug the points. Sorry. Okay, sorry, I made a mistake. Sorry when I make mistakes, but this is some internal calculation that going on. But the calculation I told you earlier is something going to be like this, like it will be first starting with the 5, then from the 5 1 it will go to the 4, then 3, then 2, then 1, and then it will multiply itself and will bring to the point of 120. I think there's some internal calculation that the idle is doing, but yes, the factorial will work this way, and it is going to do the internal multiplication and come up with a, point of 120, right? So that is one. Secondly, now let's come to the point where how Fibonacci is working, right? So let's talk about this, right? So I think we talked about this, but still again we will do that. Anyways, you can call it over here. Save as I can save as fibo.py. Okay. Okay, so we have saved it now, and just give me a second. Okay, so let's break down, how, sorry to keep you wait, right? So how basically the Fibonacci will work. So basically, as you are already aware, the Fibonacci is the series of numbers, where function 0 is equal to 0, 1 is equal to 1, and n is equal to n minus 1, right? So basically the sequence will look something like this. Just give me a moment. So it will look something like this, like f0 is equal to 0, f1 is equal to 1, f n is equal to f of n minus 1 plus f of n minus 2, right? So sorry, forgot it again. Yeah, so this is the way basically the Fibonacci is supposed to work. So the sequence would look like this. Like, let's say if I talk about index 0, value will be 0, right? Now index is 1, so the value will be sorry, so the value will be 0 plus 1, that is 1. Now index is 2, this is 2, so value will be again 1. Now we go to index as 3, so that is going to be 1 and 1, that is 2. Now index is 4, that means the value is going to be 2 and 1, that is 3. Okay, index will be 5, value is going to be 3 and 2, that is 5. And once index is 6, the value is going to be 8. So how it is working? So basically 1 is basically 0 and 1, so 1. 2 is basically 0 and 1 again, that is 1. 3 is basically 1 and 1, that is 2. 4 is basically 2 and 1, that is 3. 5 is basically 3 and 2, so the value comes to 5. And finally when we put up the value of 6, so 6 will be the sum of 5 and 3, so the value is going to come as 8, right? So once we run this particular thing, it is going to showcase you the output, right? So let's run it. sorry, just give me a moment, I need to hash out everything. Yeah, and now let's run it. Right, so now we got the values. So basically what the function is doing is that it is taking a number n, then it returns the nth Fibonacci number. It uses recursion, and basically the most important part is the base cases that we have mentioned over here, without which, which we earlier also mentioned, it can go into an infinite loop, right? If you do not mention the base cases, why they are needed, we told you that it would run forever, and the Python needs to tell it, when to stop. So step by step how this is going to happen is, on the first step the Fibonacci 6 will be called. So basically it is going to do a Fibonacci 5 and Fibonacci 4, right? That is what it is going to do. Then Fibonacci 4 is going to do a Fibonacci 3 and then a Fibonacci 2, and finally Fibonacci 2 is going to do a Fibonacci 1 and a Fibonacci 0, right? So now the value starts returning back up the call stack, right? So returning values upward. So Fibonacci 2 will be 1 plus 0, that is 1, then 1 plus 1, that is 2. Fibonacci 4 is 2 plus 1 is 3, 3 plus 2 is 5, and 5 plus 3 is 8, right? So that is how it is going. Like it will start with 0 plus 1, 1, then 1 plus 1 will be 2, uh, then 2 plus 1 will be 3, uh, 3 plus 2 will be 5, and then finally 5 plus 3 will be 8. So once you give the index on Fibonacci as 6, it will do a recursive sum, and then it will reach to the count of 8. So that is how basically the recursion will work internally from Fibonacci 6, 5, 4, 3, 2, 1, 0, and then each function call is pushed onto the stack, and once base case is hit, the values will pop back, right? So basically the one of the important point is that the same values are recalculated multiple times, because of which the time complexity for the Fibonacci is 2 raised to power n. So that is why, in the initial point of time we mentioned that the use case is basically slower in this case, right? I think the loops will be better over here, but definitely that is one of the points that we had to explain, like how can be done, right? So with this we basically come to the conclusion of today's Python video or tutorial. Please like, share and subscribe if you think that the recursion that we discussed about gave you a chance. I apologize that there were some mistakes that happened from my side, and I will try to bring up or try to do better in the upcoming videos. Thank you all.